Welcome to Dale's DIY. I just want to apologize for this particular video. Had some trouble with an older camera. We've got a new camera that you'll be seeing in some of the more recent videos, and I think you're going to appreciate the quality. So stay tuned, and I hope that the editing is not a problem because it's a camera problem. Thank you so much. Like and subscribe. We got a whole lot more good stuff coming. All right. Well, it's one of those fun times. Got some more stuff. I ordered a few things to proceed with the build. So let's see what we got. First is a box from Summit. And waiting on piston ring compressor so I can put the pistons in and get that part of the project rolling. When we were talking about setting clearances on the connecting rod bearings, and we were talking about clearances on that big end after we replaced the bolts, and we discovered that those bolts, ARP says absolutely have to resize the big end when you put in new bolts. Well, we discovered after we measured a couple rods, and we discovered on one end that there were absolutely no changes whatsoever when we pressed those in with my vise, being careful. And on the biggest change I measured was 1/10,000th of an inch, a little bit more narrow on the side, but the same on the vertical axis. And 1/10,000th of an inch, who's going to be able to machine that? So anyway, that's what we discovered with the rods. Here we go. Flywheel bolts. Here we got my ARP 40,000 silver piston ring compressor, tapered ring compressor. It's worth the time, it's worth the money, it's worth the wait. Man, you'd sure hate to break a ring and then have to pull everything back apart because you don't know you broke it till it's way too late. These piston ring compressors are just fantastic. So let's set this aside in my construction box. Got a breather. Cap, throw that under here, and then flywheel, 28 ounce, 164 tooth Summit flywheel, and they got a pretty good reputation on that flywheel for having good quality without having any run out, run pretty true, pretty straight, so that will be a good piece. Got the right bolt diameter. With these small block Fords, you got to make sure you have the right tooth count for the bell housing you have. And we have a 164 tooth bell housing. And then you have to make sure that you've got the right diameter for your torque converter. And this one here, we got the 11.5 inch bolt pattern. It looks like we might have two patterns on this flywheel. But anyway, we've got we ordered one that would come with the 11.5 inch. Let me grab a tape measure. Well, we got a 12 3/8 and 11.5. So we'll be using the shorter ones in there. And then here we got the torque converter drain hole on either way, so we can line that rascal up. On these Fords, they only go on one way. This is offset drilled, only one way. Then we've got, it's an FSI rated. Got the 28 ounce, looks like it's welded on there good. So we're good to go on that. So let's set this box aside. And I started grinding valves today too, so we'll get to looking at those valves here in a second. We'll have to discover what's wrong with that here in a while. It's somewhere in the settings, something has been changed, so I'll have to go back and reset my settings. All right, so Rock Auto, the intake and exhaust, that was kind of a fiasco trying to, when we started grinding those valves, find out that almost every single one of them was shot. I took apart two other sets of heads that I had. There was no go, man. Everything was shot. And so we bought more valves. So I got some off of eBay. I got some from Rock Auto. And here we go. Pretty decent looking valve there. You'll see here, let me take it out so you can see the margin on this. That is what they're supposed to look like. And you remember how the other ones were a lot thinner than that. Let me grab my glasses here. Let's measure it. Let's see. They said it's a minimum of 80 is what all the big dogs say. But brand new, out of the box, drum roll, 75 thousandths. So, you answer me the question, how come all the internet gurus and all the internet big dogs say 80 thousandths minimum margin on an exhaust valve when brand new out of the box there's 75 thousandths? You tell me. All right, good looking valve. Life is good. Internet gurus may not be quite as smart as we thought they were. Let's see what this box has. Need to sharpen my knife. I've been cleaning too many gaskets with it. Oh, got my comp cams lube. So we have it proven right here first that we're actually going to be using the comp cams break-in lube. So nobody can say we didn't do that. Once again, like we was talking about, you've got to have the oil additives to make sure that your lifters break in. Because what happens is your lifters microscopically wear in to your camshaft. And they're supposed to rotate and have plenty of oil with the right kind of anti-wear, anti-friction additives so that the camshaft will wear and harden to the lifters. Huh? I thought that's car parts. That's my wife's parts. She'll be happy for that. All right, so let's move on. That was a fun little break. Grinder. Okay, that's a round nose tip. This is really my favorite for porting, for kind of doing a little bit of work there. Here's more of a Christmas tree tip. This is a Chicago Pneumatic die grinder. Great little piece. Didn't cost too much money. It's really hanging in there for the duration. Got a 1/4 inch collet, and it's got a 3/8 collet that you can switch in and out on the shaft. I've already been in here doing some work. You don't want to go crazy. Remember, when you're working with these things, grab a flashlight here. When you're working with airflow, it's all about velocity. Okay? Now take a look at this intake port. Now all we've done is clean this up. This is not a full race big inch motor. This is a 302. And so I haven't cleaned out the ports after I ground. You can see a little bit of stuff in there. But anyway, overall you can see it is just cleaned up. What you want to be thinking about when you do this is airspeed velocity. Remember, if you get it too big, you lose your velocity. You get it too small and you choke it off. If you get spots that produce turbulence, your airflow is going to fall out because the turbulence will shut it off like a valve. So you can see here that I have basically this corner here. Let's see. Yeah. This corner here, these corners were actually more rounded here to kind of direct the exhaust out that way. But it was hanging up, making some problems in the port. It was getting in the way of airflow. So we just worked this edge to make it somewhat symmetrical. And looking at the flow, remember now, exhaust is flowing out this way, and intake is flowing in this way. So it's coming in this way, going out that way. So we're looking at airflow from chamber out on this side. So we're making sure that we're going to reshape all these areas to maximize the flow in the direction it's going. So this one is airflow under low pressure. It's a vacuum with the piston sucking in the air. So we have shaped this port to make it as streamlined as possible. Now if you look up here, let me shine the light, you can see right up in here on this short turn, this side of the port has got more velocity and more airflow than this side. So you want to work this side to continue the velocity and just clean up this side to try and maximize what you're going to get out of here. But if you start hogging this out, you're going to really drop your flow. So we just carefully work this side and clean up this side to maximize what we have. And we reshape that valve guide just to kind of reduce the amount of restriction there, cleaned up the castings. Now on this exhaust side, we can't do a lot, but you can see where the valve guide is, and then the air port. That's where the injected air off of that, let's see, you're probably not able to see that. How can I do this to where you can see? There. You can kind of see that. Now, the big one is the valve guide. The small one is the air port. We're going to take and bring that air port side into kind of a fin like you would on the back side of an airplane wing, because that will help with the airflow and decrease turbulence. So we're going to be careful. The exhaust port is much more sensitive than the intake port. So we're going to be real careful working those down, but we're going to make it like an airfoil on an airplane wing and try to maximize our airflow. And on that short side of the port here, we're going to work it just to smooth it out and make airflow as least turbulent and highest velocity possible. And so what you're really truly looking for is good velocity, no areas of stagnant airflow, no significant pressure areas that drop pressure or turbulence, and maximizing the amount of lift under the curve, the flow under the curve. So when you look at your, if you look at it's kind of like a bell. It goes up and then back down. As the intake valve or the exhaust valves open up, you get your flow, and then it kind of peaks and then it flows back down. So you're looking for the maximum amount of airflow within that envelope, on average peak airflow. Now the other thing we did, you'll look here, whoops, strobe doesn't help. Can you see that area there? We've kind of cleaned that up around the intake valve. There, see that? Okay, what we've done is we've just cleaned it up without getting too much, so that it decreases the amount of shrouding on that intake valve. We're 40 thousandths over, that helps decrease shrouding, but the cylinder head itself can provide some shrouding. We don't want that, and so we have cleaned that up, that area, and made it a very slight taper towards the bore. We've probably removed 1 cc of material maximum, but we cleaned it up a lot. It was pretty rough. It would have been turbulent. It actually was a bowl, and so we've made it a slight taper into the chamber to help that airflow get around that valve. We don't want to make big changes because it's not that bad. It's nothing like today's modern stuff, but we can't do too many changes without hurting ourselves. So we will finish up that porting, then we'll show you how to do a 3-angle valve job here, and we'll cut some real mild backflow angles on the valves. All right, so hope that brings you up to speed. We'll get going here and actually show you a little bit of the grinding process in the next few days. And schedule's kind of got me behind the 8 ball, but we'll get it done. And as always, glad that you guys are part of this. I hope this really means a lot to you. I hope that this helps you become proficient in your mechanical endeavors, and that you attack your next project with confidence. And I'm trying to think if there's anything I missed on the last video. It seems to me like there was something about the cam chain installation that there was a detail I wanted to tell you that I may or may not have made clear. I'm going to think about that, and on the next video, maybe I can bring that back up to speed about that detail. Man, it's escaping me. Anyway, we'll get to it. We'll try to make sure that you know everything you need to know to keep yourself out of trouble, that your first motor or your next motor will be a good running unit and serve you well and last a long time. So, and the other thing, probably harping on this a lot, but it's so incredibly true. Design your engine to the oil, or get your oil to match your engine. In this particular case, like we've talked about, that's what it was. I was going to talk about bearing clearance on the rods. The rods mic'd out to 2000s bearing clearance on the journals, on the rod journals. So my mains are miking out at 1.3 thousandths to 0.013, 1 and 3/10. And then my rods are 2000s. And my piston wall is about 3 thousandths. So I'm looking pretty good with that other crank that we put in there. And we're going to run it on 1540 because of the oil additives, but my oil clearances will work with my weight of oil. If our clearances were significantly different one way or the other, we would have to pick an oil viscosity to match our clearances. If you don't, you're going to gald pistons and spin bearings, and you're going to or lock it up and burn up a bearing. You're going to have all sorts of trouble. Your oil viscosity has to match your clearances. The old school rule is 1/1000th per inch of crankshaft diameter, but that would be like with 30 weight and some of those other things. From experience, I can tell you we'll be fine with the 1540 and the 1.3 clearance. We'll get away with that. The 2000s is going to be fabulous. So anyway, just food for thought, things to keep you out of trouble, and making sure that everything goes well on your next build. Until then, God bless. We'll catch you later.